This is a demonstration of the FermaT Workbench. The system we are using for this demonstration provides security synchronization for multiple RACF databases. So first off, we open the Workbench. And then open the project. Once listings have been loaded into the project, which I'm not showing here because it takes a while, we can look at an inventory report to see what has been imported into the project. These reports are a little hard to see, so we'll zoom in. And this is the summary report showing the number of assembler modules, copybooks, macros, and any other information from the import process, files that have been ignored, called items that are not part of the project. More detailed listing of these are in the other reports produced by the inventory system. Got the assembler module supplied, which gives lines of code, executable lines of code, and a complexity indication. Assembler macros supplied with the same sort of information. The missing called items, which are generally system macros, a report of the files allocated to the project, with name and showing you their macros, modules, and the same sort of lines of code information. And finally the listings that were imported. Other reports that come from the load and initial processing, we have a function catalog details report. Here you can select those functions you wish to report on, but we might as well look at all of them. And that's a summary of the modules, giving you the name, the executable lines, complexity, calls to and from. We'll see this information again in the interactive function catalog. External module details are those calls that are made from modules within the project that are not part of it. And you can see what they are and what they're called by. Again, usually system macros. The Workbench also does a data flow analysis of the listings, which allows us to identify dead code. And the dead code report here shows which modules have dead code and what the lines within that module are. Finally, we have an audit report, which is a sort of project summary which lists the number of functions here, the lines within the function, the executable lines, the McCabe index, which is a industry standard complexity measure, and also in more detail, module by module, the executable lines, the total lines complexity for both the imported listings and the extracted source from that. And further down we have missing items and linkage details, which is which function calls which. We will now look at some of the interactive tools, the first of which being the function catalogue, which is an overview of those modules and macros imported into the project. On the left hand side we have a tree structure here which shows split by module, macro and copybooks, and if you press the plus it expands and gives you a list of the modules. The detail panel on the right shows more detail for the selected item. If we go for module here, it lists all of the functions within the project, and these columns are sortable, so for instance you can show the most complex modules here by sorting on the McCabe column, and it also gives you a total for the system, the number of lines, comments and the total McCabe complexity. If we select an individual module, you can see this has no submodules, so there are no child functions listed, but it does tell you the number of lines and comments and complexity. And if you click on the calls tab, it shows you what it is called by and what it calls. Calls down here, largely system macros in this case, and the little red X indicates that it's not part of the project. And you can hide the details view, which, as it's not necessary for navigating the workbench, I'll turn that off for the time being. The next tool we'll look at is the function call graph, which shows the relationships amongst the modules in the project. And you can select which functions you wish to graph. As an initial step, it makes sense to graph all the functions. So with this we can use Control F to make sure that display fits in the window, and it shows the various relationships. You can use the plus and minus keys to zoom in. Or you can use the zoom tool here to rubber band a particular area of interest, and it zooms into that. In this case you can see one of the most called items of the system is a user macro which hasn't been imported. You can also choose what you want to view in terms of function types. We've excluded system macros in the initial view here, as it makes the map rather complicated. You can simplify it further by removing the user macros and only showing modules, and again Control F fits it to the screen, and that's a simpler view. And again you can rubber band to see which module is calling which. The next tool we'll look at is the text editor, which is assembler aware and does most of the things you'd expect from a code editor. It has a syntax based colouring, it also allows you to mark lines for later reference. As the tool's multi-user, by default it opens the editor in read-only mode, so that's just a warning. You can also mark blocks. So that you can find them later. As I said, the editor is assembler aware, and one of the things it's aware of is the dead code, which was analysed by a data flow analysis on import, and you can see the dead code here has been marked in a nice sandy colour. You can see it's dead code here because it's got an unconditional branch above it and no code labels. The editor obviously does a lot more than this, and just a quick idea, here's a list of the keyboard shortcuts. So it's got the standard copy, paste, find, go to next code line, mark, locating data items, marked lines, set a return point, so having found somewhere in the code you can go back to where you were first looking, and of course standard navigating controls. The next tool we will look at is the program flowchart. And like the previous graphical tools, Control F will fit it in the screen. The zoom tool lets you move into a particular part, and the plus and minus keys come zoom in and out. The program flowchart works alongside the editor, so the two are sort of complementary. So if we open up the editor, you can see some of the colouring that we put in the editor also appears on the flowchart, like these dead code part, for instance. Again, if we go down and mark some lines, they will also appear in the flowchart. And the same blocks. And you can reposition each of them. In the editor, for instance, you can say show line in flowcharts, and it highlights that part in the flowchart. You can see. Equally, we'll do the same the other way around. If you select something in the flowchart and say show line in editor, it repositions the editor to that point. We will now look at the ways the Workbench can improve the process of change analysis and effort estimation. For this we use the batch data tracker, which allows us to see the scope of a change by identifying the data items that need changing and see which parts of the project are affected by that. We start off with configure seek tables, which opens a little access application. And here we can list data items that we feel will be part of the change and see the effect. So we go for the date here and add that to our list. We can also search for strings that are comments against data items in the code if we don't know the name of the data item, for instance. So I'll use password here as it's a password date change we're considering. And having completed our list of entities we want to search for, we then do apply seek table, which pulls them out of this little database. And we can change the display on the left hand panel here, which currently lists all the data items it can find, and we change that to matched, and it lists those data items that have been picked up by our test, whether it's the comment on the password or the actual data name. And we can edit the seek status in this panel to remove those that we feel don't match. Once we're happy with that list, we do export results, which sends the list back to the Workbench. In the Workbench we can then perform a global scan, which takes that list of data items which the batch data tracker has produced and then goes through the project, identifying the modules and annotating them. It does produce a report of those hits in the assessment report. So we'll have a quick run through this. This first page is a summary showing us the number of hits, both by module name and by file, and the number of modules hit. If we look at the more detailed reports, so the module summary by name here, shows us, as you'd expect, the module name, the number of hits on this particular search, along with the existing lines of code, executable lines of code information that we've had previously. Module summary by hits shows those modules that have had the most hits, percentage wise anyway, so you can see which modules are most affected by the potential change. And finally the module hits detail, which shows for each module the field name, the type, the number of hits, and what particular part of our search list generated that hit. the system will have marked up those modules that were in the hit report there. So if we look at our module, you can see as you roll down it, then there are some marked lines within the code whereby the data items are resulting from that search. As before, if you open the flowchart view, you can also see the highlighting in the flowchart. And again, you can zoom down to a particular part. Another tool the Workbench offers to examine the scope of a change is code slicing, whereby you can identify an item of data and see which other data items might affect that and which control decisions might also affect that. So to do that, we open the text editor, find a piece of data that we're interested in. I'll pick this one, and we select that as being a code slice criteria. And go to the business rule extraction and select create annotated files. This lets you choose how complex a data slicing operation will perform. We'll go for the most simple one first, which is only looking backwards from that point in the code and only data flow. And I take the code, which is fairly swift, and open the editor again. And the system has highlighted those lines where the data could change. And this was our original selected line. And these are two downstream of that. You can see that it's changing the function data item, which is moved into this cur_p. Again, you get a view from the program flowchart. And just slightly above that, you can see the data allocations there that the code slice has picked up. And you could see more if there were more in this flowchart view. We'll now have a look at doing a data and a control flow slice. So you can see it's slightly more widespread than we first had. So if we go through the same process again, open the editor, find our data item, select it as our code slice criteria, create annotated files. This time we'll do both data flow and control flow. And open the editor again. And because we've picked control flow, there are a number of different paths that could affect that line which has the data allocation in it. Again, the program flowchart gives you a nice overview of that. See a number of decisions there that could affect the value of our selected data item. And that's it really.